Exercise 7.4, first question. You are given that NC8 equals to NC2. You want to get NC2. So first we get N. Now this implies either these two are equal, but 8 is not equals to 2, or sum of these two has to be above number. You know the last property. If you remember the last property, if two combination symbols are equal, then either A equals to B, or the sum of these two is above number. Above number is here N. Here N. So what about this? These two are not equal, so sum of these two has to be above number. So N equals to 10. So therefore here NC2 equals to 10C2. So what we'll get here? 10 factorial upon 10 minus 2, which is 8 factorial into 2 factorial, just formula. Bigger factorial in terms of the smaller factorial. So 10 into 9 into 8 factorial upon this 8 factorial, 2 factorial is just 2. This is 90 by 2, so 45. That's the value. Okay. Question number 2. Let's do the first one. Question is get the value of N. That's the question. You are going to find the value of small n. What's given to you? 2NC3 is to NC3 equals to 12 is to 1. So we just express in form of ratio. Write the formula for this. 2n factorial upon 2n minus 3 factorial into 3 factorial into here upon this is n factorial upon this minus this, that is n minus 3 factorial into 3 factorial. That's equals to 12 by 1. That's just 12. Now we'll simplify. So here 3 factorial will get cancelled. What about this? 2n factorial you can express in form of 2n minus 3. So 2n, 1 less, 2n minus 1, or a less, 2n minus 2, or a less, we'll get the 2n minus 3. Now we got this, we stop and we write the factorial upon the 2n minus 3 factorial as it is into n minus 3 and n. So this n factorial you can express in form of n minus 3. N into n minus 1 into n minus 2 into n minus 3. You got the number, we stop and we write the factorial. And this n minus 3 factorial as it is equals to 12. Okay, now you can see this will get cancelled, this will get cancelled. Here this is just 2n minus 1. You will find 2 common, so we'll get the n minus 1 upon n into n minus 1 into n minus 2 equals to 12. So this will get cancelled, n will get cancelled. Now we just simplify. 2 into 2, 4. So here you are left with just 3. 2, 2, 4. That will get cancelled with this. So finally, if you just simplify, you will get 2n minus 1 equals to 3 into n minus 2. So 2n minus 1 equals to 3n minus 6. So 6 I'll take over here. So this is just 5. And 3n minus 2n. So therefore n equals to 5. That's required value here. Question number 3. How many chords can be drawn through 21 points on a circle? So you have 21 points on a circle. 21 points on a circle. So it's like this. This is a circle here. You have 21 points, 1, 2, 3, 4, 5, 6, 7 and so on. Right? Such 21 points are there. when we get a code by selecting any 2 points. If I select these 2 points, you get a code, right? So by selecting, you see, by selecting 2 points, we get a code, remember, right? So therefore what we'll do, we write total number of codes, that's equals to selection of any 2 out of 21, and that can be done in how many ways? 21c 2 ways. This gives us the total number of selections of 2 points out of 21. So I'll get the total number of codes. If I take this 2, you'll get a code. If I take this 2, you will get code. Agar मैं ये ले लूँ, you'll get one more code. If I take this 2, you will get one more code. If I take this 2, you'll get one more code. So what you are doing basically, you are selecting any 2 out of how many? 21. So you'll get the total number of segments joining 2 different points on the circle. And how many ways 2 points out of 21 can be selected? 21c 2 ways. Remember, you are selecting here, so this is a question of combination. Now you just simplify. What is this? This is nothing but the 21 factorial upon 21 minus 2, which is 19 factorial into 2 factorial, NCR formula. Bigger factorial in terms of the smaller factorial, 21 into 20 into 19 factorial upon 19 factorial into 2. So this will get cancelled. So here this is nothing but just 210. So such 210 line segments can be obtained, that is the total number of codes can be obtained from 21 points on the circle, right? How many line segments or codes can be obtained? 210. Remember, 210 can be obtained out of 21 points on the circle here. I hope this is clear to you. Why 21c2? Because you are selecting any 2. Why we are selecting 2? Because we want a line segment. अगर ये 21 में ये भी 2 पॉइंट आप ये दोनों सेलेक्ट कर दो, लाइन सेगमेंट मिल गया. So total number of codes, it means you select any 2 from 21, and this can be done in 21c 2 ways, and just simplify. So I'll get this. Fine. Okay, so in the next question, how many ways can a team of 3 boys and 3 girls can be selected? A team of 3 boys and 3 girls are selected out of 5 boys and 4 girls. So from 5 boys and 4 girls, right? So you need to use combination concept. Total 5 boys, 3 are selected. So that can be done in how many ways? 5c 3 ways. And means into 3 girls from 4, so 4c 3. So this gives us a total number of ways of selecting, ways of selections, or number of ways of selections. Out of 5 boys, 3 girls are selected, so that can be done in 5c 3 ways. You are selecting 3 boys out of how many? 5. So how many ways? 5. From 5 boys, 3 can be selected 5c 3 ways. This gives us a total number of selections of 3 boys out of 5. And means into, remember, counting principle. And 3 girls should be selected from 4 girls. So how many ways the selections of 3 girls out of 4 can be done? 4c 3 ways. So that's your total number of selections. Now we'll simplify using the formula. 5 factorial upon 5 minus 3, 2 factorial into 3 factorial. 4 factorial upon 4 minus 3, which is just 1 factorial, and r factorial, that's just 3 factorial here. Now this is 5 into 4 into 3 factorial, that will get cancelled with this 3, and here your 2. This is 4 into 3 factorial, so that 3 factorial will get cancelled. So 20 by 2, 10 into 4, so we'll get the total 40. 40 selections can be made out of 5 boys and 4 girls, which consisting of 3 boys and 3 girls, remember. Fifth question, which is of the same type. Find the number of ways of selecting 9 from 6 red. Total 9 select करना है. From how many? From 6 red, 5 white and 5 blue. 5 blue, 5 white and 5. Right? Total you are going to select 9. If each selection consisting of 3 balls of each color, right? Total 9 selected, in which each color balls should be selected. Right. That means 3 should be from this, 3 should be from this, and 3 should be from this. So 3 balls from each color. So we'll get the total 9. That's given in the question. So total ways of doing this, total ways equals to here 3 out of 6, that can be done in 63 ways, into 3 out of 5, that is 5C3, into 3 out of 5, so again you will get the 5C3. Why and into? Because you are using the word and means counting principle. You just simplify each of this, you will get the final answer. 3 should be from 6, so that can be done in 63 ways. 3 should be 5, that can be done in 5C3 ways. And 3 should be from this 5, so that can be done again done in 5C3 ways. So this and this and this, and means by counting principle, into. So 6C3 into 5C3 into 5C3. This gives us the total number of ways of selections of total 9, in which 3 comes from each color. Now you just simplify, so you'll get the final answer. Okay. Question number 6 here. You are given a pack of 52 cards. Question is 5 cards are selected randomly, with the condition that in each selection of 5 cards, one S should be there. S means eka hona chahiye. Now you recall in 52 cards, you know total there are 4 S's that you know. So the 1 should come from this. 1 S should be selected from this 4. क्योंकि हर एक सिलेक्शन में एक तो होना ही चाहिए. Now 4 S's you already selected. 52 cards, 4 एक चले गए, तो you are left with remaining how many cards? Remaining how many cards? 48 cards. बाकी कितने cards बचे हैं? 48 cards. You want selection of 5 cards. एक एका ले लिया, तो remaining 4 should be selected from this. 4 cards from this. So 4 cards should be selected from 48. And 1 S should be selected from 4 S's. These and this. So by counting principle you have this many ways. So total ways equals to 1 should be selected from this 4C1. And means into by counting principle. The 4 cards should be selected from 48. So 4C1 into 48C1. 1 card should be selected from 4 and 4 cards should be selected from 48. I hope this is clear to you. क्यों यहाँ पे 4C1 लिखा? क्योंकि एक तो कॉम्बिनेशन में होना ही चाहिए. देखो ये 5 का कॉम्बिनेशन हो गया, बट हर एक कॉम्बिनेशन में एक तो एक का होगा ही. Remaining 4 card can be any from the remaining 48 cards, right? That's why you have total 5, remember. Now you just simplify. What is 4C1? You can verify it is just 4. What about this? 48 factorial upon, how do we write this? this minus this, which is 44 factorial into 4 factorial here. So 4 as it is, this bigger factorial in terms of the smaller factorial, 48 into 47, 46, 45 into here you have 44 factorial, and that will get cancelled with this. And what about 4 factorial? That's 24. This will get cancelled. You can just simplify this. If you simplify this, you will get 7,78,320. It's such a big number, remember, but this many ways are there. This many selections of 5 cards will be there, in which each selection consisting of one S, remember, right? I hope now this is clear to you. Question number 7. How many ways can one select a cricket team of 11 from 17 player, which has only 5 players that can bowl? So there are 5 bowlers out of 17. If each cricket team of 11, total you are going to select 11, remember. 11 players should be selected. 11 players are selected, in which it's like previous question, in which you can see 4 must be bowlers. 4 must be bowlers. So like previous one, how many bowlers are there? 5, and 4 must be bowlers. So this 4 should be selected from 5. So total 5 bowlers. So from this 4 should be selected. Not 17 में से 5 bowlers हो गया, so you are left with 12, remaining 12 players. Remaining how many players? 12. So now remaining 7 should come from these only, remember. Okay? Understood? It's like previous question. So by counting principle here, how we'll write the total ways? Total ways of selecting, total ways equals to 4 bowlers, it's written in the question itself, should come from the total 5 bowlers. So it can be done in 5C4 ways. And means into. Total how many players are there? 17. So 5 bowlers chale gaye, so you are left with 12 only. So from 12 remaining players, the remaining 7 players should be selected. देखो आपने total 11 ही select किया, 7 plus 4 11, और total कितने हैं? 17 हैं. So each selection of 11 players, 4 must be bowlers, remember. Okay. Now we'll just simplify this. Not a big task. Here you have 5 factorial upon 5 minus 4, that is just 1 factorial into r, that's 4 factorial. What about this? 12 factorial upon 12 minus 7, which is 5 factorial into 7 factorial. Now this you can write 5 into 4, so 4 factorial get cancelled. This is just 5. 12 I can write as 12 into 11 into 10 into 9 into 8 into 7 factorial, that will get cancelled with this. 5 factorial is just 120, that you can write directly here. Fine. 12 I wrote up to 7 factorial, here 7 factorial, that will get cancelled with this. What's 5 factorial? It's 120. Now you simplify this. So 10 into 12, 120, that will get cancelled with this. 5 into 11 into 9 into 8, you are having this finally. So here you will get finally 3960. Just simplify. This many total number of teams will be there of 11 players. This is the total number of teams of 11 players, in which you will find exactly 4 bowlers in each team. So here next 8th question. we have 5 black and 6 red color balls. Determine the number of ways in which 2 black and 3 reds can be selected. So 2 black should be selected, 2 selected from this, and how many reds should be selected? 3 reds should be selected. 3 reds should be selected, 2 black should be selected. From 5, from 6. So total here number of ways, total number of ways equals to, from 5 you are selecting 2, so 5C2, and by counting principle, and means into, from 6 you are selecting 3, 6C3. So let's simplify this. This is 5 factorial upon 5 minus 2, which is 3 factorial into 2 factorial. Here 6 factorial, 6 minus 3, 3 factorial into 3 factorial. So 5 into 4 upon 2 into 6 into 5 into 4. 3 factorial will get cancelled upon 6. 3 factorial is 6. 1 3 factorial will get cancelled. This is 20 by 2. So that would be just 10. 6 will get cancelled. This is 20. So finally you will get the 200. So there are 200 ways of selecting 2 black color balls from 5 black color and 3 red color from the 6 red. 200 ways are there of selecting 2 black and 3 red color balls from 5 black and 6 red. So next, 9th question. How many ways can a student choose a program of 5 courses? So 5 courses are selected out of 9 courses, in which 2 specific courses are compulsory for every student. So 5 courses are selected here. 5 courses are selected in which 2 courses are compulsory, must for each student. That means 2 should be there. Okay. So here 2 courses are fixed. So remaining 7 courses. 7 would be remaining courses. These are the remaining courses. ये तो हर एक में select करना ही है. This will be there everywhere in each selection. Total how many courses? 5. That means this remaining 3 should come from the remaining 7, remember. Fine. I hope this is clear to you. Now we did such things number of times. These are the 2 specific courses, 2 some fixed courses. This is their fixed courses. Everyone has to select these 2 courses. So these 2 courses should be selected. Now total 9 courses. So total now you are left with how many courses? 7. But from this remaining 7 courses, only 3 should be selected because total 5 select karna hai. So remaining 3 should come from this remaining 7. So by counting principle, total ways of doing this, total ways of selecting 5 courses, of selecting 5 courses, that is equals to here 2 should be selected from 2, so 2C2, and from 7 3 should be selected, so 7-3C, and because of counting principle, 2C2 is always 1. What's a 7C3? That is 7 factorial upon 7 minus 3 4 factorial into 3 factorial. So 7 into 6 into 5, 4 factorial will cancel upon 3 factorial, which is 6. So you will get finally 35. So there are 35 ways of selecting 5 courses in which 2 courses are compulsory for every student. So in each selection of 5 courses, these 2 courses will be there always, remember. Just you have different 3 courses. Fine.